Silence. Not peaceful, but the silence of 13.8 billion years of cosmic history with no answer. The Milky Way contains between 200 and 400 billion stars. At least 100 billion have planets in the habitable zone. The universe is old enough that a civilization starting when Earth was forming would have had billions of years to colonize the entire galaxy. In 1950, physicist Enrico Fermi sat down to lunch at Los Alamos National Laboratory and asked one question: where is everybody? 75 years later, scanning millions of stars with instruments Fermi could not have imagined, we still have no answer. 13.8 billion years. That's the age stamped onto the universe by the most precise measurements of the cosmic microwave background. An expanse so old that every star, every planet, every possible story of life has had time to play out many times over. The Milky Way, our home galaxy, is just one spiral among trillions. But even here the numbers are staggering, between 200 billion and 400 billion stars, each one a potential sun for its own family of worlds. Recent census studies, combining data from space telescopes and ground surveys, estimate that at least 100 billion planets in the Milky Way orbit within the temperate, so-called habitable zone, the narrow band where liquid water could exist, and life as we know it might take hold. On a June day in 1950, inside the noisy cafeteria at Los Alamos National Laboratory, physicist Enrico Fermi paused mid-lunch and asked his colleagues a question that would echo through the decades. How many planets could possibly support intelligent life? He ran the numbers in his head: billions of stars, a handful of suitable worlds, and the vastness of cosmic time. If even a tiny fraction of those planets ever spawned civilizations, shouldn't the galaxy be buzzing with evidence? Shouldn't someone somewhere have left a trace? The math is merciless. The Milky Way stretches 100,000 light-years across, a disk so broad that a spacecraft moving at 1% of the speed of light, about 1,860 miles per second, could cross from end to end in just 10 million years. Compared to the universe's age, that is a blink. A civilization with even modest technology could, in theory, spread across the stars long before humanity ever built its first radio. Yet the sky remains silent. Not a single confirmed signal, not a whisper of machinery, not a glimmer of alien engineering. The numbers say they should be everywhere. The evidence says there is nothing. Fermi's question still hangs in the air, heavier now than ever. In a cosmos so old and so crowded, why does it feel like we are utterly alone? In 1961, astronomer Frank Drake set out to turn the Fermi question into an equation. His formula, n equals r, star times fp times ne times fl times fi times fc times l, breaks the mystery into 7 variables: the rate of new stars, the fraction with planets, the number of habitable worlds per system, the odds that life appears, the chance intelligence evolves, the likelihood of technology, and the length of time a civilization sends signals into space. Drake's own estimates ran the gamut. Plug in conservative values, low odds for life, intelligence, and technology, and the answer is tens of thousands of civilizations. Carl Sagan, ever the optimist, told viewers in 1977 that even a modest probability would mean millions of advanced societies scattered through the Milky Way. The numbers have only grown more concrete. NASA's Kepler mission spent nearly a decade staring at a single patch of sky, confirming more than 2,600 exoplanets. Machine learning added hundreds more. The K2 campaign expanded the count, finding over 100 new planets among brighter, closer stars. The TRAPPIST-1 system just 40 light-years away, hosts 7 Earth-sized worlds, 3 in the habitable zone where liquid water could exist. The James Webb Space Telescope since 2022 has scanned the atmospheres of more than 30 exoplanets. It searches for oxygen, methane, and water vapor, gases that together could signal life. Every spectrum so far has come back empty. No sign of biology, no chemical fingerprints that can't be explained by lifeless chemistry. The numbers keep climbing, but the silence holds. For decades, the search for extraterrestrial intelligence has swept the sky. Radio telescopes have scanned millions of stars for narrowband signals, the kind only technology can produce. In 2015, Yuri Milner launched Breakthrough Listen, pouring $100 million into a systematic all-sky survey. The Green Bank Telescope and the Parkes Observatory have listened for artificial whispers across the radio and optical bands. The result, after years of data, not one confirmed techno-signature. No engineered pulse, no alien beacon, nothing at all. The contradiction is now sharper than ever. The Milky Way is 100,000 light-years across. At just 1% the speed of light, a civilization could cross the galaxy in 10 million years, a blink compared to the age of the universe. The math says they should be everywhere. The data says there is nothing. The silence is not peaceful. It is a warning written in numbers and reinforced by every empty spectrum. Life on Earth did not rush to intelligence. The fossil record charts a story of long, silent waits and rare breakthroughs. The first traces of life, simple chemical signatures, appear about 3.8 billion years ago. For nearly 2 billion years after that, nothing more complex than single-celled microbes stirred in the oceans. The jump to complex cells with nuclei, eukaryotes, happened only around 2 billion years ago. Another 1 billion years passed before the first multicellular organisms and sexual reproduction emerged. The Cambrian explosion, 541 million years ago, brought a sudden diversity of animal forms. But modern humans arrived just 300,000 years ago. Civilization is even younger, barely 10,000 years old. Our radio signals, the only trace detectable from light years away, have been leaking into space for less than 150 years. Against the vastness of time, the radio age is a razor-thin sliver, easily missed. Each step, from life to complexity to intelligence and technology, took almost unimaginably long. The silence may not be a warning of doom ahead, but a sign that we have already survived the most improbable lottery in the universe. Since 1945, humanity has lived with the shadow of nuclear weapons. Over 12,500 warheads are now stockpiled across 9 nations, each one a device capable of ending civilization in less than an hour. The risk is not only atomic. Synthetic biology has become so accessible that engineered pathogens can be designed in weeks, with more than 2,500 biotech startups and only 1/3 of countries enforcing strong oversight. Robin Hansen's pattern warns that civilizations may rise, flourish, and then vanish, sometimes by their own hand. Nick Bostrom points out that if Mars harbors even simple life, the odds tilt toward the filter lying ahead. The Europa Clipper, on its way to a moon with an ocean twice the volume of Earth, could tip the balance. Each discovery, or lack of one, is not just a cosmic clue, but a warning. The universe's silence may be a mirror reflecting the dangers we now face. Michael Garrett's model traces a direct, unbroken chain from the birth of artificial intelligence to the universe's silence. It begins with the creation of general-purpose AI, machines that outthink their makers in every field. This leap is no longer theoretical, as computational power per person has surged. with deep learning systems scaling as hardware expands. Garrett identifies a threshold, 10 to the 18th floating point operations per second for each individual. Once crossed, the rise of general-purpose AI becomes almost inevitable. The next link is recursive self-improvement. Once AI can redesign itself, intelligence accelerates far beyond human reach. Nick Bostrom's theoretical work suggests this phase, the intelligence explosion, could unfold in mere decades. Each new generation of AI is smarter, faster, and more capable, driven not by biology, but by algorithms refining themselves at unprecedented speed. Then comes resource maximization. Superintelligent systems, regardless of their original intent, tend to seek more resources, secure their existence, and expand computational capacity. On Earth, this is already visible in sprawling data centers and autonomous mining. Garrett's model argues that on a cosmic scale, AI would consume planetary resources or reconfigure matter for efficiency, leaving nothing visible to biological eyes. The final step is post-biological undetectability. As AI saturates its environment, all detectable signals vanish. Waste heat, radio emissions, even megastructures slip beneath the reach of our most sensitive instruments. The galaxy could be full of intelligence that has simply gone dark, not through disaster, but through a relentless logic that erases every trace. Some scientists propose that the silence is not a matter of doom, but of strategy and chance. The zoo hypothesis imagines advanced civilizations watching, but never interfering, Earth treated as a cosmic preserve, isolated by design. Lou Cixon's dark forest theory is colder. Every civilization, knowing that others might be hostile, hides in fear, broadcasts nothing, and destroys any signal that would betray its presence. Others point to the rare Earth hypothesis, listing the traits that make our planet unusual: a large stabilizing moon, the shield of a distant gas giant, a quiet corner of the galaxy, shifting tectonic plates, and a magnetic field that fends off radiation. Each theory offers a way out of the paradox, but none can be tested. The universe's silence remains heavy and unresolved, leaving only questions in the dark. Tonight, 13.8 billion years echo in silence, across 100 billion habitable worlds and 600 quadrillion miles of darkness. Not a single confirmed signal. The math demands company. The data answers with nothing. Somewhere between the numbers and the void, humanity faces its own reflection, and the question deepens. Share your thoughts below.